mindsetters, I hope all you grade 11s are tuning in and are ready for our live show today. This is Yvonne. He shall be teaching you maths Learn Extra. So get your questions in. Yvonne, what are we going to be chatting about today?
We're going to be talking about grade 11 quadratic sequences. So grade 10s, you've had your chance. I know the phone calls have been very busy. Grade 11s, we're waiting for you. Call in. We're going to be starting the show with the quadratic sequences.
Yeah, so grade 11s, get calling. And after this break, we're going to get straight into it. But before we do, like we did for the last show, we'll be giving away a Casio calculator today. And this is because this is the first time we're having our live shows this year. And we've got this beautiful new background. Let us know what you think.
All you have to do is call, guys.
Yeah, so call in. Let us know what questions you have. And this baby could be yours. Okay? See you after the break.
Hi everybody, it's good to be here in a brand new set. It's really exciting.
I think we're on the wrong camera. Wait
yeah,
till I'll start. It's okay. I think we're on the wrong camera, but here I am.
Okay.
Don't worry, guys. I think that we're going to be having a few malfunctions and a few gremlins because we're still trying to get everything, smoothed out. But that's okay. We shall be getting straight to the questions. Do we have any questions that we're going to start with right now?
We've got one question which I've prepared, but I think it's a good place just to give you an introduction first.
Okay, fantastic. Fantastic. Okay, so guys, please remember facebook.com/learnextra, also Twitter @learnextra. Get chatting to us. Grade 11s, get phoning. You could win this Casio calculator. We won't be doing giveaways every day, but just for today, because we've started, giveaways, but you never know what could happen during the week. Grade 12s, don't forget that you're up next, and get those questions in. Are we ready to start?
We are.
Or do we still have gremlins?
Okay guys, so I've started writing there what is a quadratic sequence. I hope you can see this. We are obviously just trying to get things going. But today's lesson, our opening lesson, is about quadratic sequences. Grade 11s, that's for you. So remember, it is a sequence of numbers in which the second difference is a constant. Okay? So I'm just going to write that down because that is the key. Second difference is a constant. Now what does that mean? Okay, remember that in any sequence we define a sequence in terms of Tn, okay, and Tn is the number of the sequence. So if we start by saying a sequence has got 1, 2, 3, 4 terms, etc., we are going to say it's T1, T2, T3, T4, and etc. Okay, now to illustrate what is a difference, I think I'm just going to use a numerical example. So let's see if we can scroll down here. Okay, and the example that I have is 3, 6, 10, and 15, and the sequence will continue. Before I write down the next term, let's see if we can actually use the differences in order to understand what the first, second, third, fourth, fifth missing term might be. Okay, so in terms of our differences, we go 6 minus 3, so the next term minus the previous term. 6 minus 10 gives us a 4, and 10 minus 15 gives us a 5. And I'm expecting, like I said, my next difference over here to be a 6. 6 plus 15 is 21. What do I have down here? Okay, I've just evaluated my first difference. Second difference, I'm going to do the same exercise. 4 minus 3 is a 1. 4 minus 5 is a 1. 5 minus 6 is a 1, and lo and behold, I get all 1s, and that gives meaning to what I told you before, okay? The second differences in a quadratic function, or rather a quadratic sequence, are always constant. Constant meaning they do not change. For the matrics that are watching, what that means, remember you are faced with geometric sequences and arithmetic sequences as well. How do you identify what kind of sequence you're looking at? Because part of the ball game in matric is to have a game plan for each question you look at, and you identify it by using this common difference over here. If it's the same, you are looking at a quadratic sequence. Okay, now, the quadratic sequence has what we call a general formula. Let's see if we can find a way to scroll down here. Okay, so Okay. Indiana, maybe.
Oh my gosh, are we having a few demon problems there? Have a look at the middle of
I
the
see
screen.
extend page.
You got it.
All right, guys, you got it?
I wish I could see your screen from here.
Hang in there, we're getting this right. So the general term is called Tn, and that is given by an squared plus bn plus c. Okay, and that over there is a t. Tn is an squared plus bn plus c. We call this the general term for a quadratic. Okay, for a quadratic. It does not apply to any other sequences but to the quadratic sequence, and it's something that you need to take for granted, and it's something that you need to know by heart. Grade 11 and grade 12. Okay. Now, if I then substitute for n, so I say, okay, I know that my first term is given by t1. Okay. T1 means wherever I see an n, I'm going to substitute a 1. 1 squared is equal to 1. So I have 1a plus 1n plus c. T2, okay, is equal to 2 squared, which is obviously 4a, plus 2b plus 2b plus c. Okay. I'm going to put my T3 here because I'm running a little bit out of space. So again, 3 squared is 9. I'm going to end up with 9a rather plus 3, and that's of course b plus c. And okay, for this exercise we won't go up to T4 because we simply ran out of space, but I think you get the idea. If I had to plug in a 4 there, you will end up with 4 squared, which is obviously 16, plus 4b plus c. Okay, now let's talk differences again. Because remember, I'm trying to show you that in a quadratic series, we always get that second difference being a constant. So how do I do that? I do the same thing as I did with the numerics. Okay, when I subtract T2 and T1, okay, I'm going to get 4a and 1a subtracted gives me a 3a. Okay, that obviously there is meant to be a b. Okay, because the n is 1, 1b. And 2b minus b is just plus b, and the c's cancel out. Okay, if I do the same exercise again between my T3 and my T2, I'm going to get 9a minus 4a, which gives me a 5a, and 3b minus 2b gives me a plus b, and once again, the c's cancel out. Okay, and what you'll notice here is that when I now subtract, okay, when I now subtract to get my second difference, remember this over here, let's see if we can be fancy, this over here is my first difference, I'm now going to talk second differences, and the second difference is happening down here. Okay, bear with me. So 3a, or rather 5a minus 3a, and that gives me now 2a. Let's go back to our black pen. Okay, and what happens to the b? b minus b cancels out, and great. If I had my T4 here, it would be 16, okay? 16 minus 9, okay, gives me 7a. So my other difference would be 7a. And 3b, that would be now a 4b minus 3b would be plus b. And if I had to subtract them, I would again end up with 7a minus 5a, and that would give me 2a, okay? And b minus b would obviously cancel out. So what this goes to show, okay, in a bit of getting used to on this fantastic new set that we've got, is that 2a ends up being the common difference, okay? And it is always the same when you look at the second level down. And in actual fact, that's quite an important concept for this, okay? Because as a rule, we can now deduce, since it worked for the general form, it will work for any form, okay? That's why it's called the general form. And what we can say then is that in any quadratic sequence, we have this result that 2a is equal to the second difference. And that is very important. Okay? So there's a few important things that I've spoken about here. This is one of them. Obviously, the general term formula is the other one. But using this, you can now solve any question that revolves around quadratic series. Quadratic series. And I think what we'll do, in order to actually give this stuff meaning, let's do a numerical example together, and we'll show you how it works. Okay? So, the example that I've just pulled out here is this sequence, which is 5, 12, let's go back to our black pen. I've got 5, 12, 23, 28, etc. Okay? And the instruction is to find the nth term. Okay? Find the nth term. So let's write that down here. Find the nth term. Okay, matrix and grade 11s, this is a perfectly fair question going forward. Matrix, you've obviously seen this before. Find the nth term. That could be followed by a question that says find T100, for example, in which case you would first need to find the value for the nth term. Okay? First thing I'm going to do is first differences. So 5 and 12 obviously gives me 7, right? 12 and 23 gives me 11. 23 and 28, I notice, is 15. Okay, as an exercise, if I had to say to you, can you please tell me what is the next term in the sequence? You would be able to do that at this point. Why? What I notice is that in actual fact, when I do my second difference, 11 minus 7 is 4. 15 minus 11 is 4. So first of all, I have now confirmed, great, I'm looking at a quadratic sequence. That's quite important, especially for the matrix. Grade 11, you haven't done other sequences. So if you get a sequence, it's likely to be a quadratic sequence, but you must check because it may not be. Might be a random other sequence, such as a cubic sequence, for example, in a kind of problem-solving question. Okay? But the point is that I can now actually work backwards. So my question to you is, if this is 4, that means what would need to happen here in order for this to still be 4? Well, this would need to be obviously 19. And I could then work backwards and add 19 to 28, and I could find out the next term in the sequence. Okay? Very common question, look out for it. The next thing I can now do is I can use what I've just shown you, and that is this 2a is equal to the second difference. Okay? Since 2a is equal to the second difference, 2a is equal to 4. And therefore, a is equal to 2. Okay, and I'm going to call this step 1, because step 1 is about finding a. Step 1, and step 1 is about finding a. Okay, so I'm just going to put an a in there. Great, we now got a. How do we get b and c? So to get b and c, we go back to something that we did a little bit earlier on, and it was in this general term. Now we know, okay, remember I said to you that if it works in a general term, we don't call it general for nothing. It's because it works in every kind of quadratic series under the sun. And that means that this 3a plus b over here, okay, this 3a plus b, what it means is that that will always be equal to, let's just close it and make it a little bit neater, that 3a plus b will always be equal to our very first difference, okay? So there's an a there, 3a plus b. And if I then look at the question that I'm trying to solve, what I notice is that in this case, this term here is my 3a plus b term. So what I can say now is I can say 3a plus b is equal to 7, okay? And that is step 2. Step 2, to get b, okay? To get b. So this one is here and this one is here. But remember, I already know what a is. I've already shown that. And I've worked out that a is equal to 2. So I can plug my a into this little equation that I now have. I'm going to get 3 times 2, which is 6. 3 times 2, which is 6, plus b, okay, is equal to 7. And obviously I can now solve. B is equal to 7 minus 6. I hope you all know that. And I end up with b is equal to 1. Okay, so some of you should already have the lights on here. You should already be saying, okay, I know how to now get C. For those of you that are still in the dark, we do the exact same thing that we've just done in step 1 and step 2, except we use one of the equations from the general term that have a C in it. Okay, let's go back up and have a look at that general term again. The easiest one to use is this very first one, T1. So I know that T1 is 1a plus 1b plus c. Okay? So I now go T1 is equal to 1a plus 1b plus c. Remember, I've just calculated A and B. Let's plug those in. So I get 1 times A, where A, remember, we've already said that A is equal to 2, there it is, plus 1B, which is 1 times 1, plus C I don't know yet, and that is equal to the very first term, T1. And T1 is just the very first term in my sequence, which of course is 5.
Yuval, can I ask you a question?
Yes.
Before we go to break, which we're
Sure.
going to do, Sean, Andile says, is the difference between 23 and 28 really 15? Please check that. Rectified or elaborate more on it because I'm not getting it. Does that make sense?
23 and 28. Have we
It may
done
have been from
something
a few
wrong
minutes
here?
ago.
7, 11. Okay, so I see here, I've just written, is it Andile?
Yes, Andile.
Okay, so Andile, thank you, well spotted. Okay.
Don't you love it when mine
Andile, you
says
can
it?
stand up and wave your hands. Obviously, it is not correct. And the reason for that is this should be a 38.
I see.
Okay,
I
so
see.
Andile, well spotted, hey?
Okay, well, I've got a few more questions. Shall we go to break and maybe I'll end off with letting you know what's been going on the page? Is that okay?
Sure, yeah, absolutely.
Okay, before we go to break, guys, thank you so much for joining us. I see all of you are loving it. You're on the Facebook page, facebook.com/learnextra. Also chat to me on Twitter @learnextra. You guys are saying such fab things about the set and we're having a great time. Just want to let you know, mindset is Linda Guguletu Sewundula. I hope I said that right, Linda. She wants to know the difference between a quadratic, a linear, and an exponential number pattern. So maybe we can go through it after the break. We'll have a look. And then I know that Ndomiso, you also have a sequence that you would like to chat to us about. But we'll get to that straight after the break. Don't leave your seats and get back right here. After the break, see you now. Hi guys, and welcome back. Let us know how you've been enjoying the show because we've been having such a blast. I just want to let you know again about the Casio calculator we've been giving away today. We gave away one earlier and we're giving another one away right now and the next hour too. So that's 3 calculators today. And all you have to do is please call in and give us a question, chat to the producers on the other side, let us know what you want to know, and then we'll get back to the questions. But I think we're going to finish off on a question now, and then we will continue with questions that are on the Facebook page. Okay guys, let's get to it.
Okay, hi, welcome back. We just got to finish this very last question over here. Of course, we were in the process of just writing down what T1 was. So I've got 1A plus 1B plus C. And of course, substituting our A and B values in there, I'm going to get 1 times 2, 1 times 1 for my B. C is what I'm looking for. And the first term in the sequence in this example is a 5, And of course, solving now, 1 times 2 is 2. 1 times 1 is 1, gives me a 3. C is equal to 5 minus 3, 5 minus 3. And I hope you can all see that is a 2. And what I've now done is I've solved for A, B, and C. Okay? The question asked me for the general term. And that means that I need to now write Tn is equal to an squared plus bn plus c. All I need to do now is plug in those a, b, and c values. So we can finish this question. Okay? So Tn finally is equal to an squared. A we said was 2. So let's confirm that. There we have it. So an squared plus bn plus c. I'm going to get 2n squared. Remember, I want n's in my answer because it's a sequence that I'm looking at. 2n squared plus, what is my b value? It's 1n. What is my c value? And of course, it's 2 plus 2. And that is the answer for my general term. Okay? An extension question, which kind of follows on naturally from that, is to then say, okay, can you please give me the 57th term, for example, or the 100th term, or the 157th term? And really that's quite easy because this n over here, it's like an index. It's a position keeper. It tells us which point in the sequence we are looking at. okay? It's like a chest of drawers, and n is the number on the drawer, and when you open the drawer, inside you have a term, and that term is equal to what your answer is. So for example, we can do a quick check. Let's check to see that our answer is right here, and I hope it is. So if I now say, let's confirm, for example, that T3 is actually equal to 23 using my formula, okay? Let's sub it in, okay? So I'm now going to say T3 is equal to 2 times 3 squared plus 1 times 3 plus 2, and 2 times 3 squared is 2 times 9, which is 18. 18 plus 2 is 20, and 20 plus 3 is equal to 23. So we have a winner, and you could use the same recipe to find any term in the sequence, because you now have the formula that creates all the terms in that sequence. Okay, so I mean, that is just an example. It doesn't really get much more complicated than that. What you might find, guys, in class is there are lots of teachers out there. I personally know of 3 different methods for this same kind of result. Okay, so if you have a teacher in your school that starts talking to you about doing, for example, simultaneous equations, or you may have some teachers that use a set formula for this, okay, just remember you can't pick up your hand and say, ma'am or sir, you are wrong, because normally they know what they're talking about. It just means that they have a different way of doing things, okay. This is one method. I like this method because it's quite quick, okay, and it's very easy to remember as long as you remember the general term.
Yuval, that's a very good point to make, because we've had quite a few mindsets saying, oh, but that's not how my teacher did it. So what I said to them is that they need to go and chat to their teacher and say to them, listen, this is another way, what do you think? And find the best way that suits you, really. Mindset is, I think that's the best way.
Absolutely.
I do have a question. Are you ready for it? I think it's a simple one. Are you finished yet? Or
I am finished, but should we just address the linear one first?
Yes. Let us, and then we'll get to that one. Okay, perfect.
Okay, sorry. So I know that we had a young lady by the name of...
Oh, I can't
we'll find
remember.
your name. So just to answer your question with regards to a linear sequence.
It was Linda. That's it. Do you want me to read out the question?
Name. So no, it's fine. I remember the question.
Okay, cool.
So thanks, Indiana. So in terms of a linear, it means it's going up by the same amount each time. Okay? It's very easy to make up a linear sequence because we just add the same number each time. So for example, the odd numbers. Everybody knows the odd numbers, 1, 3, 5, 7, 9. If you think about how we create that sequence, okay? So we just go 1, 3, 5, 7, 9, etc. Okay? Now what happens when you start talking first differences is that your first difference in a linear sequence will always be the same. Okay, and that is really the definition of a linear sequence. Okay, we sometimes call it an arithmetic sequence. Grade 12s, you will have heard that before, hopefully. You may have started doing now sequences in series. So in this case, we simply have a 2 as our first difference. Okay, so that addresses the linear sequence. In terms of an exponential sequence, well, that's just a sequence that looks something like 2 to the n, 3 to the n, 4 to the n. Okay, so when we now, for example, if I tell you that Tn is equal to 3 to the n, okay? So T1 is 3 to the 1, which is, of course, 3. T2 is 3 to the 2, which is, of course, 9. T3 is 3 to the 3, which is, of course, 27. And the numbers are now getting too big. My brain is getting too sore. But I think you get the idea. Okay, this is an example of an exponential sequence. And it might come up in a kind of problem solving. So for example, you might see in a test or an exam, especially in the more kind of problem solving environment where there's lots of patterns generally, you might see a question that says, can you give the general term? So exam technique, general term means you want Tn. In other words, you want to have a formula that contains n's in it. Okay? And the general term for a sequence whose terms or elements are 3, 9, 27. Okay? And the way you would do that is you would check, you would say, well, I only really know how to check for quadratic sequences. How do I check for quadratic sequences? Well, is there a common second difference? If there isn't, then I rule that out and I say, okay, there's another trick here. Maybe it's a cubic, maybe it is a squared, maybe it's something funny like 1 minus 1, 2 minus 2, 3 minus 3. We can make patterns up. As long as there's a pattern, we can make them up. Okay? But this is an example of an exponential series.
Very cool. And I think actually touching on that, Linda again has also said, like, why do you write T1, I think like 1A plus 1B plus C, and don't just write it like A plus B plus C, because putting the 1 is confusing. Is that just a different way, like we were talking about before?
Okay, so the reason for that, Linda, is because I've been teaching for 10 years, and I teach students that go from the Einsteins to the not so Einsteins, and some of them struggle with that concept and some of them don't struggle with that concept. So that's the reason. But you, as a matter of fact, are 100% right. You've been an absolutely star caller, and I think that's a really great point. Whenever you have a coefficient of 1, you're more than welcome to leave it out. I just put it in here for clarity purposes.
Okay, I thought so. And then this is the other one that I was wondering about. Nadine, I promised her that I would say that I would read her question out. She wants to know, what's the difference between arithmetic and geometric sequences?
Okay, so I'm not going to get too into that now, guys, because I don't want to get too involved in the grade 12 syllabus. Okay. I've already partly, Nadine?
Yes,
Nadine, I've already partly answered that, okay? When you're thinking of an arithmetic sequence, I mean, I guess we can spend exactly 1 minute on it. But very simply, an arithmetic sequence is where you have a common difference. In other words, the first difference is always the same. And that is always equal to T2 minus T1, which is equal to T3 minus T2. In other words, whenever you subtract the next term from the previous term, or rather the previous term from the next term, you'll get the same result. Okay, that is an arithmetic or a linear sequence. In a geometric sequence, instead of adding and subtracting, we are multiplying. So I'll just give an example, but we won't get more involved in it there. Of course, what that means, Nadine, is you're going to have to watch the show for the matric section when we do the whole section on sequences and series, and it'll be really exciting for you to wait for that. But, okay, I'll just give you a quick preview. So the geometric sequence, we're going to go T1, T2, T3, and an example of that will be, for example, if I start at 2 and I multiply by 3, I'm going to end up with a 6. And then I multiply by 3. I'm going to end up with an 18. And then I multiply by 3. Okay, so I can keep going like that forever. The point is that we keep multiplying. We call it a ratio, a common ratio. And that ratio, just for interest, is given by T2 over T1 or T3 over T2. Okay, so that's just a bit of a preview. Nadine, if you're in grade 11, you don't need to worry about that now. If you're in matric, don't worry, you're going to get lots and lots of exercise in this.
Good answer. Do you have any other questions, or shall I give you one from the page? Those are always the scariest ones, right?
Okay, no, well, I actually have prepared a second question for today. Thanks, Indiana.
Okay, fantastic. Well, let's go to a break, and then we can go through those questions. I just want to say thanks so much to all of you guys who have been tuning in. I'm just going to read a few names. Pearl, she says, the show is really helping me. Kalon, he wants a few study tips for maths. We can run through it quickly at the end. Linda, all of you guys, thanks so much for joining in. We're going to go to a break. Remember, at Learn Extra on Twitter. I've only had like 3 or 4 people chatting to me. Guys, come on. I need something to do too. Also, facebook.com/Learn Extra. Call in. We want to chat to you quickly during the break. Questions. If you're the first caller, you could win this amazing Casio calculator. Okay, we're going to the break. Run to your phones right now. Hi guys, and welcome back to Learn Extra Live. I hope you guys are having a fantastic time enjoying our new set and chatting to us on facebook.com/Learn Extra. We've had a bit of Twitter activity at Learn Extra. No one's called in yet for the Casio calculator. Perhaps maybe what the best thing to do is to please send a question to our Facebook wall or onto Twitter with something, a question that Yuval is talking about. So if he's talking about something and you don't understand, please let me know so I can like jump in and be like, yo, Yuval, they don't understand, and then hopefully you can win this beauty. So let's get right to it. You ready?
Okay, here we go. So thanks, Indiana. Okay, so it's the same kind of thing. I mean, we can make up a million quadratic sequences. Here's one. So the sequence looks 1, 7, 19, 37, and 61. Okay? And the first question is asking, what is the next term in the sequence? So question 1, next term in the sequence. I'm just going to write next term. Okay. So I hope you're all thinking first differences, second differences. Remember, this question might appear in a section, in a random section. So you need to be thinking maybe it's quadratic. How do I check? 1, 7 is 6. 7, 19 is, of course, 12. 19, 37 is 18. Is that correct? Yeah. So 37, 27. Yeah, that looks right to me. And of course, 61 and 37. Well, I can already see that I've got a pattern here. Okay. So 6 to 12 is 6. 12 to 18 is 6. So this will also be 6. Okay. So 18, I'm expecting to get 24 here. And 61 minus 37 is 24. Okay. And what will be my next difference? Okay. So what I'm doing now is I'm showing you a technique to find the next term in the sequence. Okay. So 24, I'm going to add 6. I'm going to end up with 30 here. And then I work backwards. So 61, obviously I'm going to end up with a 91 here. That's the answer. Okay. So nothing too tricky there if you understand how the common differences work. Question 2 is to find the nth term. Okay. Find the general term. Find a formula. And I'm going to say an algebraic formula. So this is question 2. Find an algebraic formula for the nth term. Nth term. Okay. So I hope you're all screaming into your TVs now. Tn is equal to an squared plus bn plus c. Okay? Which means, okay, that T1 is equal to 1 squared. So 1a plus 1b, 1a plus 1b plus c. This is a c here, eh? C. T2, what is T2 equal to? 4. 2 squared is 4a plus 2b plus c. And I'm going to go one more. T3 is equal to 3 squared, which is 9. 9a plus 3b plus c. First difference, okay? First difference. 4a minus 1a is 3a. 2b minus 1b is plus 1b, and the c's cancel. Next one. 9a minus 4a is 5a. And 3b minus 2b is plus b, and the c's cancel. Okay, so I've done a bit of work now. Okay, it's good to actually do this because now, okay, I go back to what I know. I know that 2a is equal to the second difference. So that means that's a golden rule for the section. Okay, and I've proved to you why. And what is the second difference? Well, we've already worked that out. Okay, right here we showed that the second difference was actually a 6. The second difference was actually a 6. Okay? And that means that 2a is equal to 6. 2a is equal to 6. Which means that a is, of course, equal to 3. I'm halfway there. Okay? 3a plus 1b is my first difference, my first term. 3a, let's extend the page, 3a plus 1b is equal to, now what was the first term in the first difference? Let's see if we can find it. First term in the first difference was this term over here, 6. Okay? First term in the first difference. Why? How did I get that? I went 7 minus 1 and I got a 6 here. Okay, so then I can set this 3a plus 1b equal to 6. And I already know that a is equal to 3. So I'm going to get 3 times 3 plus 1b, or plus b as Linda correctly said, is equal to 6. And I'm going to end up with 6 minus 9, and I have b is equal to negative 3. Okay, 3 times 3 is 9. 6 minus 9, b is equal to negative 3. Right, let's continue here. What do I need to do next? I now use my first term, so T1. T1 is equal to 1a plus 1b plus c. And what is T1? T1 is the very first term in the sequence, which we've said is equal to a 1. There it is. Oh, okay, we've lost our way here. Just bear with us. Okay, we're going to go to a short ad break, I think.
Oh, are we going to an ad break? Or I can chat to you about a few things that people are saying on the page. I know, guys, we've been having technical difficulties with our phone. So, I mean, Linda's actually said, and Linda has been chatting to us the whole time on the show, actually. And she said, been trying to call you, but it's just saying the mailbox is full. I would have really loved to have won the calculator. You guys are really helping me because I was lost. Thank you. And I'm loving the live show. I'm going to watch it always. Watch out for me. You know what, Linda? We are watching out for you, and I reckon we're going to give you the calculator, especially since our phone isn't working. So, guys, hopefully our phones will be working from tomorrow on. And Linda, for being such an amazing mindsetter, this one is for you. And Yvonne, shall we carry on with the question?
Yes,
or
we can.
Or we can go to ad break? No, let's carry on.
Okay, we can just finish this question. Hang in there, guys. We're almost through this question. Okay, so 1a plus 1b plus c. We've said that the first term is a 1, and we know all our terms now, so I have a times 1, which is, of course, 1 times 3, plus 1 times negative 3. C is what I'm looking for, and that's equal to a 1, because 1 was the very first term in the sequence. Okay, there it is. 1, we'll try and circle that again. Hopefully we won't have the same results as last time. And just to solve, okay, so minus 3 plus 3 cancel out, c is equal to 1, and we are done here. Tn is equal to an squared, so a is 3n squared, plus bn, which is minus 3n, so there's a minus there, plus c, which is plus 1. Okay, and if I then extended that, and I said to you, great, you've got Tn, can you tell me what the 50th term is? It's really just a case of substituting that n equals to 50 into this general term over here, and Bob's your uncle, you've got your answer.
Okay, perfect. Okay, guys, we're going back. Well, we're going to have a little break, and then we're going to be back for 5 minutes. We're going to have a look through the page and see if we can find the most important questions. Unfortunately, we can't get through every single question because we've only got an hour, and I mean, that's not enough time to get through everything. And I know a lot of you are like saying, come on, please answer this. So Yuval and I will go through everything during the break and get those questions answered for you. 5 minutes left, guys, and then afterwards, grade 12s, you better be joining us. It's going to be a great show, and you know what? If you learn early and you learn extra, I'm telling you, any of my mindsetters from last year will probably tell you the same. If they had been watching from the beginning of the year, you will pass, and that's a promise from me, Indiana. Okay, after the break, see you now. Hi guys, welcome back. We've got about 5 minutes left to our show. Congratulations to Linda for winning the Casio calculator. I will be contacting you on how to get this lovely prize. I just want to let all the mindsetters out there know, I think it was Sharon and Lebogang, they keep saying, please can you go over the next chapter of the books, you know, skip the chapter of the book. Guys, we're working through this. It's a process. We're going to start from the beginning and end at the end. So, yeah. Let's do this properly. And I think we've actually got a question here from Ndomiso. Are you ready? Okay.
Far away, Ndomiso.
Okay, here. This is what he says. He said, find the constant difference in the sequence. X minus 3, and then X minus 1, and then X plus 1. Oh, and I've actually seen on the page right now, about a minute ago, Lebogang actually answered Ndomiso on Facebook. So let's see if Lebogang is right.
Okay, so Ndomiso, I haven't got the question in front of me, so I'm just going on what you've said. When you say find the common difference, I'm assuming, okay, that we're talking about the first differences over here. Okay, but the answer, when we get an answer, we'll know. All right. And remember, differences, it's called a difference because there's a subtraction involved. All right. And remember, this over here, let's just rule this off over here. Okay, whenever you're working with terms that have more than one term in them, so for example, x plus something or x minus something, it's always good to put brackets, okay? Because it's going to stop you from making stupid mistakes like not distributing a minus or something like that, okay? And especially since we're working with differences, that becomes doubly important because I'm going to say T2 minus T1. And then I'm going to use T2, which is x minus 1. And you can see now why it suddenly becomes really important that you have a bracket. Didn't put your bracket in, you're not going to distribute this minus over here. Okay? That's the first comment. Let's see if we can get an answer here. So I'm going to get x minus 1 minus x plus 3. Okay? What does that equal? X minus x, well, that actually cancels out. 3 minus 1 is 2. So I'm hoping that I get the same answer for the next two terms. If I don't, well, then you've stumped me. Okay? So let's see now. I'm going to say T3 minus T2. And remember, if it's a common difference, it means that it's applicable to every term in the sequence. So I'm going to now do a quick check. I'm going to say, okay, let's check T3 minus T2, the first difference. T3, okay, it's up here. Here it is, x plus 1. X plus 1. So again, I'm going to use my brackets. X plus 1 minus x minus 1. I seem to have run out of space here, so I'm just going to do this on one line. Okay, so what does it equal? X plus 1 minus x plus 1. Same theory as before, minus x plus 1. Okay, and have a look. Your x's now cancel, and 1 plus 1, well, that gives me a 2. So then the common difference in this case is 2. Okay, so that's quite nice. They could have said this is a linear sequence. Okay, they should have actually told you that this is a linear sequence or an arithmetic sequence or something like that in the question. And then they could have said, find the first difference or find the common difference. Okay, or prove that this is a linear sequence. Okay, and you would do that by showing that, okay, every term that I subtract from the previous term, I'm going to get the same result. This is not a quadratic sequence, which is what I've been talking about for most of the hour. This is now another kind of sequence. So again, a bit of a problem-solving question for the matrix. It's a totally fair question in the sequences and series section. Grade 11s, it's just introducing you to the concept of a linear sequence. Okay?
I think everyone had lots of fun with that question. I think we've got about 1 minute left. I'm just having a look to see what everyone's saying. I'm going to read out a few of your mindsetters' comments. Tack, I hope I'm saying your name right. Name right. The show is very interesting. I'm really learning. So yeah, guys. And a lot of you are saying you cannot wait for exams. And I know exams seem super far away, but I think the easier and the quicker you start learning extra, the more you get on it. And I think also, like Yuval said, this is really good. I mean, grade 12s, watch the grade 11s show. I mean, it's always good to like brush up on your knowledge and get things, get things right. Yuval, any questions, anything for closing off?
No, I mean, just remember that I just want to really give a message to everybody, but the matrix more. Part of the question is identifying what you're looking at. And people, they don't read the question properly. And they don't think about the question first before they do stuff. Read the question, work out your game plan, and in sequences and series, that game plan is always, what kind of sequence am I looking at? Am I looking at a quadratic? Am I looking at an arithmetic? Or am I looking at a geometric for the matrix? Or something else? Okay,
cool. So, grade 12s, don't forget that you guys are on next. Same applies, facebook.com/learnextra, @learnextra for Twitter. Please join us straight after the break. And don't forget that we've got live shows on all through the week up into Thursday for grade 10s, 11s and 12s. So join in, and that's going to be for 8 weeks up until the 22nd of March. So guys, there's no excuse. Get learning extra, tune in and be back after the break.